So hello everyone, we are here for the tutorial about cryptography. One moment please, I'm just preparing myself. Hope everything is going fine on your side and you can dedicate 30 minutes to this hopefully fun webinar. All right, I'm just opening a little slide here. I prepared a slide deck and here we go. Let me share my screen on the other side to show the slide deck. Okay, welcome to this webinar. It's about cryptography and more fun. We will be, in this webinar, we will be trying to solve a problem of encrypting passwords. We're doing so without closed software, just with open source software. So this webinar will be basically 30 minutes. We will look into the disclaimer part a little bit, just to make sure we understand risks. We will also look to how to create keys, how to make use of cryptography, just to try to encrypt and decrypt simple things. And finally, we can also discuss about practical uses of this on the day-to-day basis. So let me just, before we start, let me just show you where you can learn more about my projects. This is my blog and website. Here, there's a part of blogs and works. All works that I created so far are here. Some project about learning data science through trading, and some other projects like saving time with Excel and cryptography. There you can find, obviously, some small description, as well as the blog where I basically describe motivation about each course that I'm doing. So feel free to use this and check out this little article, which will be, by the way, which is just kind of a summary of what we will be doing today. Okay, so today I would like to start with just a little disclaimer. But before we start, even with that disclaimer, let me just check a little technical thing with you. I would like you to make sure that you there's cards. If you're watching on YouTube, there's some cards which you can choose and click, and those cards are basically indicating there's some questions on it, like polls. And so please, at the moment, if you can hear me well, could you please just say that using those cards on the right side part of the screen from you. Okay, thank you very much for those who do this. And let's continue with the disclaimer. So cryptography is, first of all, today all methods are provided for learning purposes. I would like to ask you to try on the test dummy data first to actually understand what you do, because there's a risk of losing data if you suddenly overwrite something or delete something. Also check laws of your country for if you are allowed to use this tool. Sometimes I heard there's this is not really appreciated by the country. Okay, let me just go to the very, very short theory about the methods we are doing. And later we go to R to actually practically make things by ourselves. Maybe before we continue, I would like to ask you to use a second card, which you can find on the right side of your screen and rate your knowledge about cryptography. What is your knowledge currently about it? I would say um, 5, or which if you say 5, that you means that you're expert, and maybe 1 if you know nothing about it. Maybe rate 3 if you use some tools on the cryptography and so on. So feel free to participate in the poll. It's not mandatory, but it's just a curiosity from my side. Okay, let's move on with this little theory. Cryptography is basically is letting us to kind of change the way our communication is look like, and make it illegible for adversary. We do so with this communication protocol, which basically can make communication illegible, and then when we need it, it can make it legible again. And the process is called encryption when we make it illegible, and decryption when we make it legible again. And we will be using, in this case, public key cryptography is a protocol that uses part of private and public key and make it happen. So in general, it looks like this. The person here on the right is having this private key. This person is giving a public key to another part, and the other party is encrypting the information, sending that through the adversary. Adversary can well receive this information as well, but without this red private key, it's not possible to decrypt this. What we'll be doing today, we'll be using R. We will take a text object, for example, persistently written file with the passwords, and that we will send this file to R, right, internal, and in our algorithm, which we will be using OpenSSL cryptography toolkit, which will get public key and process this information together with this key and retrieve us some encrypted information, which we'll write persistently as some file object, which we can send, store, and so on. And backwards process for decryption is the same. We will send both encrypted object and private key to this R machine, and R will process this data through another algorithm, and it will write back our file with passwords. Now I believe we are ready to make next steps, which will be to just do it with R Statistical Software. Please download this repository, which you can find here, and open RStudio. And right now we will be creating key and encrypting information. So let me just switch to RStudio right here, and here we go. I have here this repository, and first thing we'll do is to create a key. So please open this tutorial keygen, which you see right here on the bottom. I'm just opening it right now. So this is the code which we will be executing. I hope you all had a chance to decrypt it so you can follow. Otherwise, pause the video if you watch it later. Good. So this tutorial is basically will help us to getting started fully with cryptography using raw package OpenSSL. There are other packages that are kind of wrappers around this, but we will be creating kind of a little bit our own thing. So just if you never used it before, you need to uncomment these lines and install those two packages. I have already done so, but you can, if you select and press Control Enter, you will be able to run just those lines of code. I have already done so. So I will also, I will only execute this line of code, which I just named it here, and this line of code. So I'm loading libraries. This is the main library which we will be using for cryptography, and this library is just a helper. It will help us to read and write files or make some data manipulation more easily. So the next step we'll do is to create a folder, directory with just here. It will be a place for our keys. This is just a simple directory. If this directory doesn't exist, we will create this directory. I will just execute this command here, and immediately you see there's a folder. Here you have a folder here. And next thing we will start using actually this OpenSSL library to actually generate private key. For those who curious more why we're using these functions, simply type here down below $OpenSSL package, and you can have a help menu. This is basically, it's explaining all the functions, what you want to do, like creating some random number generators and so on. Well, what you don't need to do it now, but just in case you want to have any help on the function, you can just type $RSA keygen and just hit enter, and you'll find all the help menu here. Basically, this tutorial was created by reading this help menu. So this is kind of not a secret, right? So right now, before we go next, let me explain what it is for those who don't know. Basically, this will this will make sure that the output from this function will be parsed to as a first argument of the next function. So you kind of understand it more easily and naturally, the flow of what we're doing. So if we execute this even just without this information here, and if we execute this line of code, we will generate standard random private key, and we will store it persistently. This is the object. If I now change the name of this key and execute this one again, this will be another key. If I execute this line once again even more, this will be another random key. So be careful when you execute this. You should not execute it basically more than one time. And when you execute this code, you need to be really careful to maybe to back up or the old key and make sure that that you're not losing original one. Maybe we'll discuss about risk slightly later. So there is an argument here, bits, which allow us to specify, I don't know how long this key should be, so we can customize this number out our likings. Too little number is not allowed, but a bigger number will just make it a little bit longer. The key will make it longer. So this is the way we can do. So let me just delete the old one, the one that I just created here. And we have, let's assume we have this one key, okay? Right now, I would like to actually generate quickly, extract public key from this object. So what I will be doing, I will read this file here, I will read it and extract the element, which is called public key, and write this element persistently right beside this one, this private key. So I'll just need to execute this lines of code. And here we go. We have this public key. This is a little smaller. And right now we will, let's inspect both those objects. Okay, let's understand what are those keys about. By the way, this is all you need to, this part of the creating key is already done. Okay, if you don't want really understand how they are, you don't have to execute this line of code. Basically, to generate the thing I want to, the message I want to give is that to generate your private and public key is just enough to basically to execute these 4 lines of code. If you execute those, you get pairs of private and public key, which you can use for encryption. Remember to execute it only once to make sure you have a backup copy of your key and kind of managing properly these keys. More on that, I'll talk a little bit later. So right now, let's inspect a little bit. Let's go a little bit deeper to understand what is in this key. Okay, can we decompose it? Let's try to do this. So let me just create an object in this global environment by reading this key from memory here. Okay, and let's see what happens. So I have a list here, which is already generated. And by using a function, I can obviously look at this list by by executing command structure. Expand it a little bit. And this is our private key. This is exactly as we specified, the size, type of the key, and this object is public key, and this is the row vectors which are the numbers that are randomly generated numbers which made key they make this key unique. This is the SSH is sort of a hash, let's say unique identity of this object. We will talk about hashing it slightly later. So let me just accelerate a little bit, and I will now execute this line of code to also get a public key object. And this is how we do this. What I wanted to show is that this public key object is basically nothing else than this part. So this part here. So it has all the same characteristics like SSH hash and fingerprint, and 2 things from the 2 vectors from the bigger key, which are here. They are all exactly the same. So let me just to finish off, let me just show you how to extract this random number. Just as a curiosity, you can just type pub key, public key, dollar, and data, and dollar again, and put n. So let's extract this number here. This is the number we just extracted. So it's a long random number, which is basically public, and make this will make all this fun. By the way, this is not strictly relevant for you to know, but just to make sure that we know a little bit what are those private and public keys, we could a little bit experiment with them. Now, let me just delete those objects. They are kind of secret, and this one as well. And let's go to the second part of our tutorial, which will talk about encryption. Funny part, encryption. Right here, we will encrypt phrase "Hello World" and create message file. We will write it persistently, and we'll write it just right here. So what we'll do, we'll take this message, serialize it, which means we will put it to row vector. Okay, so and then we will pass this message to the encryption function. This will create a list of objects, also row vectors, and we will write what we got to the file. So here we go. We have our message encrypted as a file stored persistently, which we can share, we can delete, we can send, you can save to USB, you can email it. And obviously, the same thing we'll do, we can do also with private key. So before we were using public key, and now we can also use the private key. For example, if you use that one yourself, you can not even generate a public key, but you can use always a private key. For example, I'm having like a USB key, in which I can store my my private key, and I keep that in a safe place. For example, this is kind of an idea which we can make. So if I execute this one, it will just be exact same thing, and just here it's just overwritten. Okay, if you want to practice, we can just replace this with some data object, and maybe let's do it like this. I can just copy this, and I can do ars encrypted, and here I will get this object cars. So if I execute this one, it will just created this encrypted object. So this way we can encrypt data sets, for example. Okay. Now let's go to the next step, which is we will decrypt this information, right? So to decrypt this information is also very easy. We read back this information. First, we will read this as encrypted list to our session. Then we will use this function decrypt envelope, where we provide those arguments. We'll say where they are. We'll have to tell where is the private key. Attention, this is important. Without private key, we cannot do this. And if we execute this function, we'll have our row vector, which we just need to unserialize. If I do this, I get back my message hello world, which you can see right over here. And obviously we can remove this object from the global environment when we don't need it. Now, to decrypt cars encrypted object, it's basically pretty much the same. You just need to make copy of this code, and instead of message.encrypted, you can write cars, and yeah, and then it will everything will work. So here is the dataset cars. It's perfectly the same as it was before. Okay, this was basically all about encryption and decryption. Last thing I wanna mention is about hashing. So we let's just make a little trial with hashing to try what it is. I have the dedicated script, R script. But before we go, I would like to ask you, what is your knowledge about hashing? Have you ever tried it? Have you ever used it before? There is a card on the right type of the screen. Please, if you don't mind, share with me if you know about this and what is your level of knowledge about it. Thank you very much. Let's continue with our tutorial. So I'll just go back to my script, and here we go. There is a little tutorial hashing, which you can just open and also execute line by line this code. So right here, I will create. I will create this. I will execute this code, which will create unique hash from this object. So the hashing is basically it's a way to well, encryption is possible both ways, and decryption is only hashing. Sorry, is just one way. You just create using the algorithm. You create sort of a unique string, which can be of different lengths, and you can create those kind of abracadabra things that we can often see when we're browsing, and sometimes browsers creating those hashes, kind of creating unique sessions for us. So if we create this hash here, if we execute it again and again, this will be always the same one. If I change anything, like adding one more space, or maybe I will just maybe, I can make a little funny experiment. Let me just change this one to German, right? To German language, and I will type O in German, right? Let's see what happened. It's still the same, but now let me write O in Cyrillic. I need to remember. Okay. So looks like the same, right? But if I execute it, it's completely different one. So it's a kind of way to check identity, right? So if it's some people are doing this tricky things, right? They substitute one letter, and it looks like the same, but this way you can check it, right? It's pretty fun. Huh? It looks like the same thing, but not. So if I I go back to English, and I just put O back again, and I execute this one again, it will be always back the same thing. So what we can do instead is also we can pass together with MD5 function, um, we can use some sort of a key, and we can type any other information to make this thing unique. For example, you can I don't know, record position of your mouse, or make something really unique to generate this hash a really unique way. And this can be used, I believe, for generating like random passwords. If you don't have any ideas how to generate something unique and random, you can use these tools here. You can practice more with by reading this help description to this one. I believe the time is over. This this webinar should be about 30 minutes, which we already are. So let me just maybe go back to my presentation and ask you, what is your knowledge about cryptography now? Can you do now cryptography yourself? Could you now answer this question in this little card, which you find once again there? And last thing to tell is make a little summary. I would like to make this little summary here, which just to demonstrate, which basically to tell that I was very surprised to learn that cryptography is accessible using R Statistical Software. You basically don't need to have any other software loaded. No other key generation software, nothing. You can just use our open source software, which is I trust more open source software like that, which is which is spread all around the world and accessible to thousands of people. There are many use cases are possible. What I've showed is just kind of some simple use cases just to give you a bit of salt of the cake. But there's a lot more things to try. On my, I have built a course, Udemy course about this. Let me just show you it quickly. This course is called Cryptography is More Fun with R. It is, you can get it on my website down here in the section works. Here you can find it under cryptography right here, and here you can find the coupon. I'll really appreciate if you use this and get this course done. Otherwise, you can just use coupons from which are stored here. This is also a coupon which you can use. So this course was created to actually show all possible ways to use cryptography. An example of storing, say, encrypting your passwords. In this course, we're doing things step by step, a little theory, step by step, very, very accurate, step by step with exercises thing. And this chapter is helping you to basically really, really deeply understand what is going on, understand all the risk. There is a even quiz to let you check your knowledge and check out that you're currently ready to go. So feel free to check this course. And yeah, last things, once again, I recommend it to use it frequently. Try on the dummy data to make sure that you know all the time what you're doing if you decided to use R as a mean to cryptography. Okay, this is all. Thank you very much for attending this webinar or watching it later. I would like to ask your feedback. There are some, feel free to rate this webinar using always those cards on the side of the screen. And don't forget to visit my blog, where you can find all my other projects that I'm doing on Udemy, which basically help to educate ourselves around computer and data science, help to save our time to let computer do most of the annoying jobs. So thank you very much for attending this webinar. I'm looking forward to see you on some other ones, and I'm wishing you a nice day. Thank you.